Hello everyone, your radar contact and welcome to another VAS Aviation video. Welcome to another meteorology video, and today we're going to look at the terms QFE, QNH and QNE, which is from the pressure and altimetry lessons. So grab your pen, take your notes and let's do it. Okay, so first thing you have to know is that pressure decreases with altitude. So as we climb, pressure decreases, less pressure, and as we descend, the pressure increases, more pressure at the bottom. So first thing we're going to look at is QFE, and the QFE is by definition the pressure at the airfield, or the pressure at the station it was measured from. So the QFE is the pressure at the airfield. A very simple way to remember that is if you read QFE, QFE is the pressure at the field, QFE. So QFE is the pressure at the airdrome. So if you set QFE on your altimeter instrument on the window, the altimeter will give 0. Imagine we have the airport. This is the airport and we have our aircraft here sitting on the airport and we set QFE. So QFE will be across here, whatever the pressure is. So our altimeter instrument will measure the level from the aircraft to the QFE datum. So if we're sitting right here, the difference between our aircraft and the QFE datum is 0. So the altimeter instrument will read 0. Now imagine we're flying here. Now the altimeter setting, the difference is between here and the QFE datum, or isobar. Isobar is the line joining points of equal pressure. So this is our datum because we have the altimeter set on QFE. So our altimeter will read the difference between our aircraft and the QFE datum. And this difference right here from our aircraft to the QFE, to this line, is called height. And height, it's the difference in level between our aircraft and a point on the surface of the earth. Now the next term that we're going to look at is QNH. And QNH is also by definition the QFE reduced to mean sea level. In other words, QNH is the pressure at mean sea level. So whatever the pressure is, the QNH datum or the QNH isobar will go over there at mean sea level. Now if we have an airport, imagine we have an airport here now. This is our airport at mean sea level, any airport near the shoreline. If we are sitting here and we set QNH on our altimeter, now the altimeter reads the difference between our aircraft and the QNH datum. And the datum is here. So at mean sea level, the altimeter will read 0 here. But now imagine we are flying here. And we have the QNH set on the altimeter. Now the difference from our aircraft to the mean sea level is this distance. This is the QNH at mean sea level. And this distance from the aircraft to mean sea level is called altitude. And altitude is the difference between any point in the sky down to the mean sea level. And more correctly, this is called indicated altitude. This is very important for all those students because there are many questions about this. Indicated altitude is the QNH altitude. from the aircraft down to mean sea level. Now, as I said, if you set QNH on your altimeter, it will give you the distance between your aircraft down to mean sea level. So imagine our aircraft is now sitting on this airport. We are here. And we have our QNH. Now the difference between our aircraft and the QNH datum is this distance. Now this distance, by definition, from any point on the surface of the ground down to mean sea level is called elevation. So we deduce that if we set QNH on our aircraft while sitting on the ground, the altimeter will read the elevation of that airport. There are many questions again about this, so keep that in mind. Elevation from the surface down to mean sea level, height from a point in the sky down to ground surface, and indicated altitude from a point in the sky down to QNH. I also want to remind you that this is considering standard atmosphere, because later on we'll see that there are some errors, temperature errors, that we'll have to correct, but that is more advanced and we'll leave it to a future video because there are more terminology and more errors we have to calculate. Now, next thing we have to look at is QNE. And QNE is by definition the international standard atmosphere pressure, and it is 1013.25 millibars or hectopascals. Hectopascals or millibars are pretty much the same. If you're in the United States, they use inches of mercury to measure pressure, and the QNE in the United States is 29.92 inches of mercury. Now the QNE measures our level from our aircraft to the 1013 pressure datum, wherever it is. Imagine we have the 1013 isobar running over here. So if we are flying here, if we have QNE set on the altimeter, which is 1013, it will measure the difference between our aircraft and the 1013 datum, wherever it is. Doesn't matter if it's here, because isobar constantly move. So 1013 can be below mean sea level or above. Wherever it is, if we have QNE set, the standard altimeter setting set on our aircraft, it will measure the distance between our aircraft and the 1013 datum. And why is QNE used? Well, as we depart from an airport and as we climb, as we go through the transition altitude, we change from QNH to QNE. And as we descend, we change from QNE to QNH. And why is that? Well, if you're flying a light aircraft at very low altitudes, as you fly, the air traffic control will give you the updated QNH. So you are flying in the area with that pressure and you have the altimeter correctly set. Now, that is not practical if you're flying at very high levels, like airliners, and for very long distances. It's not practical to be changing the QNH over and over again during a 14-hour flight. So that's why we use the QNE. So above the transition altitude, all airplanes are using the QNE setting. So all airplanes are measuring their altitude from the very same datum. That is also important for separation, because all airplanes are flying from the same datum and measuring altitudes from the 1013 isobar. Now this distance right here from our aircraft to the 1013 datum is called flight level. or also called pressure altitude. And that is what I wanted to differentiate between this altitude, indicated altitude down to the QNH, whatever the QNH is, and pressure altitude, which is always measured from the aircraft to the 1013.25, which is the standard. Pressure value. Now, this being said, keep this diagram in mind. Hope it makes sense to you. If you have any doubts or any questions, please let me know in the comments and I will try to help you out. Now we're gonna look at a couple of questions from the question banks. Very basic, very simple. They are about this, so let's do it. Now the first question says, an altimeter adjusted to 1013 hectopascals indicates an altitude of 3,600 feet. Should this altimeter be adjusted to the local QNH value of 991 hectopascals, the altitude indicated would be, and these are the four options: 2,922 feet, 3,006 feet, 4,278 feet, 4,194 feet. So we're given three values and three pieces of data. We have a QNH value of 991, and the QNH is the pressure at the mean sea level. So the QNH isobar will go through mean sea level, and we know it is 991. Now our altimeter is adjusted. Instead of 991, we are setting 1013 on the altimeter. Remember, as we climb, pressure decreases. As we descend, pressure increases. So the 1013 isobar will be somewhere below the 991 isobar. Somewhere, we don't know where. And from this datum, from the 1013 datum, we're flying and we are reading from there 3,600 feet. Now the altitude indicated, if we set 991, that's what they're asking for. We want to know what will the reading on the altimeter be if we set 991. We need to know this distance. So to measure this distance, it's obvious that this blue distance is the black distance minus this distance. And how we calculate this? Well, you have to know the gradient for the pressure, and that is how pressure changes with altitude. And there is a fixed value of 27 feet per hectopascal. And here's a little piece of advice that I want to tell you. If I remember correctly, there are 3 subjects within the ATPL examinations that are about altimetry, and these are instruments, general navigation, and meteorology. From my experience, I can tell you that you can use 30 for most exercises in instruments and general navigation, but I highly recommend, if they're not telling you otherwise, that you use 27 for meteorology problems. Because if you use 30, you may end up having an answer, light, don't go out. You may end up having an answer halfway between two of the answers given. So you have to use 27 to be more accurate and more precise, and end up having an answer closer to the correct answer. You don't want to lose time during the exam, so just directly go to the 27 feet gradient. So pressure changes per 1 hectopascal, pressure changes by 27 feet, or as we move 27 feet, pressure changes 1 hectopascal. So that's what we want to calculate here. It's the difference in altitude or in height, in level, in feet, from the 1013 isobar to the 991 isobar. And that is pretty simple. From 1013 to 991, that is a difference of 22 hectopascals. And we have already said that pressure changes 27 feet per 1 hectopascal. So we just multiply 22 times 27, and that is 594 feet. So this distance from the 1013 datum to the 991 datum, or isobars if you want to call that way, is a difference of 594 feet. So now that we know that this is 594, we can easily say that this x is 3600 minus 594, which is 3006 feet. So if we reset the altimeter setting from 1013 to 991, every time we rotate 1 hectopascal, the altimeter reading will move 27 feet approximately. So if we move from 1013 to 991, the window on the altimeter instrument, it will say from 3600 feet to 3006 feet. Now let's take a look at another question. The altimeter of an aircraft is set to 1013.2 hectopascals, which we know is QNE standard. The aircraft has to land on a point with an elevation of 290 feet, where the QNH is 1023 hectopascals. Assuming that 1 hectopascal corresponds to 27 feet, they're already giving you the pressure gradient, so that's cool. The reading on the altimeter on the ground will be 20 feet, 11 feet, minus 10 feet, or 560 feet. So they're giving us, again, 3 pieces of data. We know that the elevation of our airport is 290 feet. So this airport, to mean sea level, is 290 feet. They say the QNH is 1023, and the QNH is the pressure at mean sea level. So the 1023 isobar is going through mean sea level, and they say it is 1023. Now the thing is, we have the altimeter setting on our aircraft set to 1013. So remember that pressure decreases as we climb, so the 1013 isobar will be somewhere above the 1023 isobar. This is Q, no Q, this is just 1013. So they're asking for the reading on the altimeter on the ground, but with 1013 set on the altimeter. So they're asking for this distance. Now how can we calculate this distance? Well, it's clear that this distance, small distance, is the big distance minus this distance. So we can calculate this distance very easily, because it's the distance from the 1023 isobar to the 1013 isobar. The difference between these two isobars is 10 hectopascals. And we said, and actually it's on the question, that 1 hectopascals corresponds to 27 feet. So ten hectopascals times 27 feet is 270 feet difference between the 1023 isobar and the 1013 isobar. So this middle distance is 270. We said that the small distance is the big distance minus the middle distance. So 290 minus 270 is equal to 20 feet. And that is the reading that our altimeter will read when our aircraft is on the ground at this airport and we have 1013 set on the altimeter. Now, taking advantage from this question, I'm going to create another question for you, and that is calculate the QFE at this airport with the information given by the question. So while I am removing all these calculations, you have time to calculate the QFE. I hope you're doing it. So remember, the QFE is the pressure at the airfield. So the isobar of the QFE will go through the airfield, whatever the value is, which is actually what we want to find. Now we have the distance between the elevation. We have actually the elevation. We have the distance from the airport to the QNH. And we said that QFE is the pressure at the airfield. So it's pretty obvious from the diagram that the QFE will be the distance from the 1023 to the surface, and that distance is 290 feet. We know the pressure gradient is 27 feet per hectopascal. So we need to know this distance, but not in feet, in hectopascals. So 290 feet divided by 27, we're going to use the 27 value, will give 290 divided by 27 is 10.74. hectopascals. Remember that pressure decreases with altitude. So if the QNH is 1023, the QFE will be 10.74 hectopascals lower than QNH. I want the QFE very, very precise. So 1023 minus 10.74, I'm sorry, 10.74 is 1012. The QFE is 1012.26 hectopascals. Okay, so that's it for today about meteorology and some basics of pressure and altimetry. This was very simple and basic today, but we'll go through more advanced theory and more difficult problems in the future. So as always, let me know in the comments any suggestions, doubts, or questions that you may have, and I'll try to help you out. Thank you very much for watching. Squawk VFR frequency change approved, and see you in the next one.